Homework question number 11 for section 2.2 is asking a company's total cost in millions of dollars is given by C of t equals 130 minus 70 times e to the negative t power, where t is the time in years since the start-up date. So this is what I'm seeing. When they started, the cost was down here. Okay, when they first started. And then what happened? In the first 5 years, the cost is going up like crazy. I wonder maybe because they have to buy a whole bunch of new supplies and stuff, like new equipments. But then after maybe I'm seeing this is year 0, year 5, year 10, 15, 20, 25, and 30. So after year 5, the cost is not really increasing much. It's kind of remaining about the same. Maybe this company, when they first started, they bought a whole bunch of equipment and stuff in that first 5-year period. And after that, it's not really costing them so much to run this. All right, so what do they want? Find the marginal cost C prime of t. What does that mean? Okay, well, that means, I should write this down. This is important stuff. This is change in cost. Oh, hold on. How about I write this? So C prime of t is equal to derivative of the change function with respect to t. So what does that mean? That means the change in cost with respect to time in year. So how is the cost changing? Like in the beginning is increasing, so we're expecting to see a positive number, okay? But after 5 years, I don't think the cost is going down. I think it's just about the same. It's a constant flat line. So after year 5, I'm expecting that the marginal cost will remain close to 0, right? Because it's not going up or it's not going down. So that's what marginal cost is. What's the change in cost per year? As we go from year 0 to year 1 or year 1 to year 2, how is the cost changing? Finding it isn't that difficult. I just have to take the derivative of this C of t, which is 130 minus 70 times e to the negative 1 t power, okay? So that was the function. I just need to take the derivative of that, okay? So what's that going to be? C prime of t is, agree that 130 will just give us 0, right? That's the constant. But next I need to do negative 70 times negative 1. That is positive 70, right? That's positive 70. And you have to copy down the exponential term exactly the same. So that is it. That is the marginal cost, C prime of t function, okay? Now, given that, let's find the change, the marginal cost at year 0. Okay, so how is the cost increasing or decreasing at year 0? I have to do 70 times e to the negative 0th power. That is 70 times e to the 0 power. That is 70 times, that is 70 times 1. I want you to remember that anything to the 0 power is just 1. So what we got is 70. Now, how much money are we talking about? Look at that. C is in millions of dollars. So 70 millions of dollars per year. That will be the answer. So 70 millions of dollars. Okay, so hold on. Let me go ahead and write the answer in context of this problem. So I'll say the answer is 70. And for million, we need 6 zeros. Okay, and that's positive. It's going up like crazy. And the time period, the t was number of years. So that is the marginal cost at year 0. Now, how about at year 3? You see how year 3 is probably slowing down, so we're expecting to see something smaller than that. So let's go ahead and plug in 3 into C prime. Oh, and I think I'm going to need a calculator for this part. I have to do 70 times e to the negative third power. It's going to be approximately, all right, I'm going to go open up a calculator, okay? I need a scientific calculator. I've done too much math for today. Or 70e to the negative third. Now listen, that is the answer. I can go ahead and write this down real quick. 3.485094786. But don't you remember, we're doing millions of dollars, right? So what I'm going to do is, I'm going to multiply this decimal by 1 million. Times million has 6 zeros. 1, 0, 0, 0, 0, 0, 0. So what is the marginal cost at year 3? The marginal cost is still going up because it's positive. Is 3. I think I can put a comma there. I don't know how to read this just yet. Let me copy this down first. 485, comma, 094 dollars and I don't think they care about the cents. It's 79 cents, but I can say the marginal cost at year 3 is 3,485,485,094 per year. Compared to $70 million, this is less, right? But still, the marginal cost is positive, which means the cost is going up. The cost to run this company is going up at year 3. Okay, next. Now what's this? They want us to find limit of this cost function as t goes to infinity. So what does that mean? If you think about it, we wait infinite number of years. Like let's say this company started in 2000, but we wait until like 3000. Well, maybe that's too far. Like maybe like 2500. Like long in the future. What will their, how did they word this? What will be the company's total cost? Total cost. Maybe I was reading it wrong earlier, but you know, the math is all good. Company's total cost. How much does this company cost? So that was saying. Okay, so if you keep on waiting, what will be this company's total cost? In like infinite future. That's what they are asking. So all right, hold on. I'm gonna go ahead and copy down C of t first. C of t is, hold on, I'll copy this part. Copy. I'll bring it down here. But I don't think I want to copy it exactly the same, okay? I want you to see that the second term has a negative exponent. So what I can do is 130 minus 70 divided by e to the positive t power, right? I can do that. I can send this to the bottom of the fraction. Send that to the bottom of the fraction because it's as an exponent, it's as a negative exponent. Now, if you think about this, if t gets infinitely big, let's see if this makes sense, okay? If t gets infinitely big, we are dividing 70 by a huge number. Does that make sense, right? If t gets really big, t gets infinitely big, we end up dividing $70 or $70 million by a huge number. Okay, so just to show you real quick, if I do 70 divided by 1,000, that's 0.07. 70 divided by 10,000, that's 0.007. 70 divided by 100,000, it's so small they're using scientific notation. What is it approaching? If you divide anything by a huge number, it's approaching 0. So guess what? The limit as t approaches infinity of c of t is approaching 130 minus 0, which is 130. So that is, using the unit in this problem, $130 million. So this company's cost will be $130 million, and it's not gonna get any more expensive, okay? Because that's infinity, okay? It's not gonna get any more expensive than $130 million. Okay, let's do the next one. They want us to find the limit is this time the marginal cost approaches, the t approaches 0 of the marginal cost. So if I copy down our derivative function, c of t, what was that? That was 70 e to the negative third power. So what are we asking? We're asking, if you wait infinitely long time, how fast, or I'm sorry, not how fast, how much will this company's cost increase or decrease, okay? But you know, this is what I noticed, guys. In this picture, I saw that the graph kind of flattened out, right? It's not really growing, or it's not increasing or decreasing, so it's not gonna change. And you know what else do we see here? If that's 75, this must be 100. This must be 125. We can see that the as it goes to the right, it's approaching slightly above 130. So I think we can see that the y is approaching 130. And that's what we got from doing the limit, right? Algebraically, I can see that the line is approaching a y value of $130 million. But this time, it's talking about the increasing and decreasing of this line. Looking at how this line is almost flat, I think we should get 0. But let's take a look. So if I rewrite the c prime of t, I can write this as 70 on top of the fraction, but put the, where is the t? I forgot to write the t. I'm sorry, I was writing the wrong function. Guys, this is the last video. So I've been doing calculus for a little too long. I'm gonna go take a break after this. All right, so this was the derivative function. So this is 70 divided by e to the positive t power. So what we did was we sent this to the bottom of the fraction because it has a negative exponent. So let's think about this. If the denominator gets infinitely big, as t gets infinitely big, 70 is getting divided by a really, really big number, right? So what is something, or 70 divided by a huge number? 0, okay? So the limit as t approaches infinity of that marginal cost function is simply 0. And if I were to put unit here, I can say that's $0 million per year. What does that tell us? Their cost is not increasing or decreasing after a certain point, okay? The company is gonna remain the same as $130 million. It's not gonna grow, or it's not gonna get any smaller. So that's it for this application problem, and this was from section 2.2, homework question number 11. Okay, I think the next one will be short. All right, I'll be right back.